Welcome to C Programming Tutorials. If you haven't subscribed to the channel, I would appreciate that you do that so that you can be notified of any new tutorials that I post. Today's tutorial, we are going to see why you cannot return the pointers to the local variables of a function. Okay, and why that's a big no-no. You just cannot do that. Okay, and in the previous tutorial we basically learned about stack, what stacks are and how they are used in function calls. Okay, so we learned that stack is anything basically a data structure that actually represents the last in first out principle, which means anything that if the data is coming in the order in such a way that the way it's coming in, it is pulled out in the reverse order. The last data that came in is the first one that's pulled out. Then we say that that data is basically following LIFO principle, last in first out principle, and basically we implement it in the form of stack. So we also saw that the way functions are called, main is our very first function. It calls some function, suppose func1, right? And then that function called func2, okay? And then this function called func3, okay? Let's imagine. And then these functions are basically, they return back, right? One after the other, right? And since the last function that was called is the first function that returns back, and these functions cannot return unless, the functions which were called after it, they basically are finished, they return first. It means that the last function that was called is the first function which has to return. Then this function calling is actually following the last in first out principle, right? Now main function can basically, remember, it called this func1, then func1 called func2, then func2 called func3, and then it went back. Now after that the main function could potentially call another function, right? I don't know, g1, okay, and then g1 could call another function, g2, okay, and so on, right? And then suppose g2 just returned back, and then g1 returned back, and we came back to main function. Okay, now look at the way. Now suppose func1 has a variable called integer f1, right? func2 has a variable called integer f2, and func3 has a variable called integer f3, and g1 has a variable called I don't know, a1. We don't want to call it the same name as the function name. That's not going to be good. And g2 has the variable called a2. Okay, these are the local variables. The way we define the local variables, we already know, right? These are the variables which are declared right after the braces start of a function. Like in this is the main function, and we declared them right here. These are called local variables. So suppose this function has this variable and this function has this variable. For example, I'm just showing all of them as integer. These could be character type or float type, or they could be arrays, or they could be structures, struct variables, anything. As long as they are inside this function, that's what we are talking about. But let's look at them, how these variables are created in memory. They actually created on stack. Okay, and this is how they look like. That this is the stack, just like the stack of plates. Okay, so this is the first function which is called is the main function, right? I should basically, let me see if I can raise it. Let's see, let me raise this guy here. Okay, and let's write main outside. Okay, and this main function does not have any local variable, so that's fine. Okay, now func1, when func1 is called, the stack this is the stack. Stack is basically the part of memory which is allocated for the use of the local variables, to create the local variables on. Okay, these memory locations are going to be used for these local variables. Okay, now when it calls func1, what happens is that a piece of the stack right after main, where main ends, that piece is actually allocated for this function func1, and inside it we will have one variable called f1. Okay, this memory will be enough to basically hold f1, plus it's also going to hold any parameters that this function might have. So we will allocate a space for that also. So this whole thing is called a stack frame. Okay, and this stack frame basically is for this particular function f1, function func1, and this func1 is actually the space for this function func1 is created right after the space for main. And when this func1 calls func2, what happens is that on the top of the stack, just like we were like putting plates on top of each other, the next plate, which is basically the stack frame for this function, is going to be created right on top of f1 of func1 stack frame. This is func2. Okay, and inside it there is a variable f2, and if there are any other variables, they will be created here also, and if there are parameters, they will be created here. And remember, this size could be totally different from this size, because depending upon how many local variables are defined in func2. And similarly, then func2 calls func3, so a frame is created for func3 here on stack. Okay, and the variable f3 in it, and plus any parameters here, and any other variable as well. But when func3 returns, what happens? When func3 returns, this memory is freed up as if it was never used before. Okay, so this whole thing frees up. Okay, and then func2 executes, and then func2 finishes, right? And then func1 finishes. So func1 will finish, and then we will have main function. When main function finishes, the program ends. So main function never finishes until the end of the program. The point is that after func1, look at what's happening here. When func1 completes, g1 is called by main. So what's going to happen? Where do you think the memory for g1, this integer variable a1, is going to be allocated for? It's going to be created on the top of stack. Every new function call, the variables are allocated from the top of the stack. What is the top of the stack right now? Right here in the main. Okay, so we will create g1, a space for g1 here. Okay, and the variable name a1 is going to be used here. And then this g1 is going to use variable a1, and is going to change the value of a1 and all this stuff. Now remember, before this, func1 was located here also. So the variable f1 was pretty much located at the same location as a1. Now f1 does not even exist, because this function has already returned. Now a1 exists. The value of f1 is not guaranteed to be there. Okay, a1 could overwrite very easily, right? And similarly, when g2 is going to be called, it's going to be using possibly the value, the space that was used before for func2, and the a2 will be probably created right on top of where f2 was there. Okay, and so on. So I'm going to stop here, and I'll continue this tutorial in the next video. So keep watching. Thank you.